Let's solve this problem. They have given that page size equal to 2 power 15 bytes. Then what does it mean? How will logical address will look like? Logical address will have one thing is page number field, another one is page offset field, and again I am assuming that it is a byte addressable system. Okay, since they have given that number of pages equal to 2 power 7, page number field will have 7 bits. And also they have given that page size equal to 2 power 15 bytes, page offset field will have 15 bits. So what is the size of the logical address? 15 plus 7 is nothing but 22 bits. It is the total size of the logical address. And so I can write here as 22 bits, and logical address space will be 2 power 22 bytes, right? Then let's see about physical address. How will physical address will look like? They have given that page size equal to 2 power 15 bytes, and so frame offset field will have 15 bits. This is frame number field, right? See, now we need to calculate frame number field, right? Number of bits in frame number field. How can I do that? See, they have given two things. One thing is page table size, and also they have given this number of pages. If the number of pages is 2 power 7, then the number of page table entries will also be 2 power 7, right? Will also be 2 power 7. Also they have given the number of pages as 2 power. Also they have given that page table size equal to 2 power 256 bytes. Equal to 256 bytes. Now from this, can we calculate size of a single page table entry? We can definitely do that, right? See, we already know that number of page table entries into size of a single entry equal to page table size. This is the formula we already know, right? Now from this they have given that they have given the page table size, which means they have given this part, which is nothing but 256 bytes. Also they have given the number of page table entries, this part, and it is nothing but 2 power 7. Now from this, can we calculate this thing? We can calculate this thing, right? Size of a single entry. Size of a single entry is nothing but 256 bytes divided by 128, right? 256 divided by 128, which is nothing but 2 bytes. See, what is the unit of this 256? This is nothing but bytes. Fine. What is the unit of this one? It is nothing but 2 power 7 entries, right? Number of page table entries means the unit of this thing is entries, which is nothing but, this is nothing but entries. So bytes per entry, right? See, the unit of 256 is bytes, unit of 128 is entries, so unit of this thing is nothing but bytes per entry. What does it mean? Size of the 2 byte per entry. Size of the page table is nothing but 2 bytes per entry. Okay, so from this we have calculated the size of a single page table entry, and which is nothing but 2 bytes. So from this we can say that frame number field will be 2 bytes. 2 bytes is nothing but 16 bits, right? 2 bytes is nothing but 16 bits. See, one thing you need to understand is page table entry is nothing but frame number. In a single page table entry, we will have the frame number field. And if a single page table entry size is 2 bytes, then frame number field will also have 2 bytes, and 2 bytes is nothing but 16 bits. So I have written here 16 bits. Now what is the total size of the physical address? Total size of the physical address is nothing but 16 plus 15, which is nothing but 31 bits. 31 bits. See, bits is very important, okay? Don't get confused. It is not bytes. So size of physical address is nothing but 31 bits. Now they have asked number of bits in page offset field, okay, which is very easy. We have calculated it, right? It is nothing but 15 bits. Now what is the number of frames? That really depends on frame number field. Since frame number field has 16 bits, number of frames is nothing but 2 power 16. We will have 2 power 16 frames. Now they have asked page table entry size. We have already calculated, right? What is the size of a single page table entry? That depends on frame number field, and frame number field is 16 bits. So answer for this thing is 16 bits. The most important concept coming to this problem is this formula. Okay, from this formula we have calculated the size of a single entry. Now if size of a single page table entry is something, say x, then the frame number field will also be the same, right? It is nothing but x, and that is how I have calculated the physical address size. Once the size of the physical address is calculated, calculating the physical address space is straightforward, right? So once if the physical address size is 31 bits, then the size of physical address space is nothing but 2 power 31 bytes, since it is a byte addressable system. Fine.